since you already know how to do 1 and 2, I'm going to let you do that in your groups. Find the area between the curves. So let's find the area trapped between the curves. Okay? On the given interval. So most of the people in your groups don't do 3 and 4 yet. Just do 1 and 2. First one. So at least saw that everyone's area shaded was good. This is from 0 to pi, right? So some of you have been setting up in 2 intervals, which is fine, but technically both sections, because some of you have divided it here, technically both sections don't they have the same upper bound, upper curve? So we can do it in 1 interval from 0 to pi of 1 minus sine squared x dx. Now when we're doing this, what does dx represent again? Because this will apply to the second page. What does dx represent? The width of what? Dx represents the width of the rectangle. So we're doing vertical rectangles with integrating with respect to x. And it's an infinite number of rectangles, right, being added together. Okay, so when we integrate 1 and we get what? X. What do we get when we integrate negative sine squared x? Okay, so you take positive cosine squared x. Now make sure it always goes backwards. If we took the derivative of cosine squared x, this is an f of g of x, where f is, well, let's see. F of x is x squared. G of x is cosine x. So f prime is 2x. G prime is negative sine. So we get 2 cosine negative sine x. Is that what we have up above? Negative sine squared. How do we integrate sine squared? What? Okay. So rewrite it. Sine x all squared dx. Then what? So we want to change it to sine cubed. Well, or cosine cubed. And divide by, okay. So same thing. If we take, make sure it goes backwards. If we take the derivative of 1/3 cosine cubed x, we're going to get negative sine squared x. Would you work it out? This one, let's use our calculator and type it in from, go to the, I don't remember what the abbreviation is, the calculator. The rest are just polynomials. Math, number 9, right? F int. 1 minus sine squared x. If you have the old version, you have to put with respect to x, comma, 0 to pi. Do you know how to type 1 minus sine squared in your calculator? You need to just do 1 minus parentheses sine x parentheses squared. Comma x, comma 0, comma pi. And what do you get? Oh, 8, we could say, right? Okay, so it's squiggly without sign because we rounded it. Now the next one, for sure you can do without a calculator. You should know what both of these graphs look like. This graph has an x squared, has the highest power, so it's quadratic. Okay, notice the negative. If I rewrote this, it'd be negative x squared plus 4. So it should be a concave down parabola with a vertical shift at 4. 1, 2, 3, 4. Okay, standard parabolas go down 1, right and left 1, down 4, right and left 2. And this one, rearrange it as well. We have our y-intercept is 1, and our slope is down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. What? Oh, whoops. Nope. Yeah, okay, right here. There we go. Okay, so down 1, right 1, down 1, right 1. So that's not actually as pretty, it's just where they intersect. So that's what you would have defined. Now, when you did a calculator, how would you do it without a calculator? Find where they intersect each other. Yep, you set them equal to each other. So we have 4 minus x squared equals 1 minus x. It looks like it's going to be a quadratic. So you're going to get everything over to one side with the x squared positive. So I'm going to move, because this is a negative x squared, I'm going to move it over to the right. Negative 4, and add the x squared. And then I put it in standard form, I have a positive x squared minus x, 1 minus 4 is negative 3. Okay, Reed, how do you solve a quadratic? What? Okay, and factor, yep. So two numbers that multiply to negative 3 and add to negative 1. Does that come out nicely? Two numbers that multiply to negative 3 and add to negative 1. 3 and negative 1, or negative 3 and positive 1, right? Do those work? No. So factor is not going to work in this case. So what's our other option? Quadratic formula. Negative b plus or minus square root b squared in parentheses minus 4 ac all over 2a. So we have 1 plus or minus the discriminant. Negative 1 squared is 1. Negative 4 times 1 times negative 3 is positive 12. That's why it doesn't come out nicely, because it's irrational. Square root of 13 over 2. Okay, plus and minus. So let's get, looks like we have, what is 1 plus square root of 13 divided by 2? What's that decimal? What are the two answers here? 2 point something. I don't have that. Did you start parentheses before you divided? Yeah, you need parentheses before you divide. $2.3028. Now, we rounded that, so what should you do with that decimal instead of rounding it? Yeah, so I'm going to store this as, pick a letter, A. And that's when I'm with John, right? Oh, no, sorry, it was X. Okay, and then do the other version, which is the minus version. If you're doing all of that in one section of your calculator, you need to put parentheses around the numerator before you divide by 2. So 1 minus root 3, make sure all that's in parentheses before you divide by 2.
We need those seniors who are scheduled to make testing to order the 119 now. They know who they are, students, seniors doing make testing.
Okay, what's 1 minus square root 13 divided by 2? Okay, so let's store that as maybe B. Right? If you're storing something as a letter, I would write down on the paper what you're storing so you remember. Okay, so that would be our left template here. So we have B and we have A. Okay, so now we can integrate, right? Top minus bottom. We said that lower bound is actually B and our upper limit is A. So which one's the top? Curve. What curve's on top? Yeah, 4 minus x squared. Minus, I'm going to just change the signs. So it's -1 plus x, all of the x. So maybe we can do it in 1, antiderivative instead of breaking it up into 2. Okay, it looks like those decimals aren't so pretty, but you stored A and B, so with your calculator, I don't know if you know how to do a calculator, but apparently they don't come out like this. With your calculator, go to math. Make sure, remember, in order to use your calculator to get credit, you have to have written this. If you don't write this, set up the interval, or integral, I should say, we won't give you credit. So, f and int, type in your function, comma x, comma, now I did the letters backwards, so lower bound is B or upper bound is A. 4 minus x squared plus 1 plus x with respect to x, comma alpha B, comma alpha A. Okay, that's the area. Here we Good. Now is it okay to round? Yeah, that's your answer. So don't round there. You're rounding just to write down so you know what the intercepts are. But you should use the stored values when you continue to solve. Okay, so those are all finding a vertical rectangle with dx. Okay? Moving over to 3 and 4, please. We are again integrating the area between the curve. Oh, looks like we have 3 doing on go. Y equals x squared, that's a problem. X plus y equals 2 is what type of line? It's a straight line. And the x-axis, so bounded by 3. Where is that area? Yeah, it's right here. That's the area. Okay, now we've been doing top minus bottom, right? But what's the top function? Yeah, there's two. So you have some options here. Okay, let's split our page here in half. We can do it two ways. If you like top minus bottom, we have to do two separate intervals. Okay? And we need to know again where the parabola and the linear line intersect. So this one actually comes out as a nice point. So we need to take those and set them equal to each other. So this should be solved for y if we're going to set them equal to each other. So that would be y equals negative x plus 2. Let's find out where they're equal to each other. We have x squared equals negative x plus 2. Where does the quadratic intersect the linear line? So since x squared is positive, I've moved everything to the left this time. To have positive x minus 2. This one should factor nicely. But two numbers multiply to negative 2 that add to 1. What? So x plus 2 and x minus 1. Those are factors though. They're not the 0. So you apply the 0 property. You get x equals negative 2 and x equals 1. So this one would be x equals 1. X equals negative 2 is over there. Okay, and we need to also know the y coordinate. So you can plug it into either one. You plug in your x is 1. 1 squared is 1, or you can put it in here, negative 1 plus 2 is also 1. Okay, plug it in to either one of those. So we have the point 1, 1. So we can, if you like, top minus bottom, so we can set this up into two intervals. I'm saying wrong vocabulary today. From 0 to 1, what's the top minus the bottom for that section? It's the parabola's on top, x squared minus, what's the bottom? Actually, the x-axis, which is 0. Which you don't really have to write the 0, but just for these purposes. Plus, we have another integral. Ethan, this green term over here, from 1 to, oh, I guess we should find out what that is. What's the top curve? Yeah, so negative x plus 2 minus the lower, upper curve minus lower curve is again 0. Okay, what is our upper limit here? What's the x value of that intersection? Yeah, it's 2. Because our slope is down 1, right 1, we can know that that's 2. Okay, so we can do it in two separate intervals, 0 to 1 of x squared dx plus 1 to 2 of negative x plus 2. Remember that all needs to be in parentheses before you put the dx. Negative x plus 2 needs to be in parentheses. Okay, Alex, what's the antiderivative of x squared? Good. 1 third x cubed. Now those it has its own limits from 0 to 1. Plus, you see what's the antiderivative of our next one, negative x plus 2? Good. From its own limits from 1 to 2. So you plug both of them in. Upper minus lower, 1 cubed minus 0 cubed. Is it okay if I pop the 1/3 out front and just times it? Yeah, that's just a multiplier. So that just becomes 1/3. Now the other one, we have negative 1/2, plug in the 2 first, plus 2 times 2, minus, plug in the 1. Don't forget that you're actually minusing both pieces. Both of these need to be minus, so you can either change both sides or put it in parentheses or brackets so that you are minusing both. So let's see, 2 squared is 4. Divided by negative 2 is negative 2 plus 4 minus, well actually it'll be add 1/2 minus 2. Okay, so we have, oh look, negative 2 is a positive, or is negative 4, so those all cancel out. We have 1/3 plus 1/2. So we're going to have to get a common denominator, right? 6 and 6. So 2/3 plus 3/3 equals, or 2/6 plus 3/6 equals 5/6. And you know what 5/6 is as a decimal? I think it's 0.8. Pretty repeating. Yep. And the repeating part only goes on the 3. Okay, that's one way to do it. That takes 2 intervals. We could also do it with respect to y. Who would you like that name, Jack Johnson? Is that like a country singer or something? Maybe it's a whole. I don't know. I'm actually sure. Okay. So we've been doing a vertical rectangle with the x. Couldn't we also do a horizontal rectangle, flip the graph, and there's a distinct top and there's a distinct bottom, or right minus left? So that's what we're really doing today. Is we're changing our interval with respect to y, dy. Otherwise, somebody is actually going to have to chop up into multiple intervals in order to integrate with respect to x. Okay, so if we change it, our bounds are now y bounds, and it's right minus left. Okay? Because the positive side is on the right, and the smaller or sometimes negative side is on the left. Okay, and Misha, what's the right curve? Yes, okay, but this time we're integrating with respect to y, so we need to get it in terms of y. The way we have it here is in terms of x. So we're going to resolve that. Instead of x plus y, or y equals negative x plus 2, we're going to move the y over. So x equals negative y plus 2. So we solved it for x. So we get it in terms of y. If we're integrating with respect to y, we should have some y variables. So negative y plus 2 minus the left. Now the left curve is normally y equals x squared. But we want to solve for x so that we have the variable y to work with. Okay, how do we get to solve for x? Yeah, square root. So we get x equals square root of y. And in this case, because we actually see the graph and we have the x-axis as the bound, we only need the positive square root. So we don't need the negative square root because we don't have any, because of the x-axis bounding it, we don't have any of the negative portion. So minus square root of y. All of that will be integrated with respect to dy. So our limits of integration need to be with respect to y. Still upper on top, lower on bottom. So let's What's the lower bound there? Mm-hmm. 2. How high does it go? All of these are on y equals 0, and the highest point is on y equals 1. Because before, we did bounds from horizontally 0 to 2. Now we're doing vertically, like the y-axis, 0 to 1. Okay? So integrate negative y, we get negative 1/2 y squared plus 2y. John, what's the antiderivative of negative square root of y? It is 1/2, so we have to up it. Mm-hmm. And this is all from 0 to 1. So same as before, we plug in the upper first, plug in 1, wherever there is a y. Minus, plug in 0, but every time we plug in 0, it's just going to be a 0. So I'm not going to worry about writing all that work out, because I'll just do it. Okay, we'll just simplify that and see if we get the same as we got before. Oh, I put a 0 there. That should be a 1. Okay, 3 at 5, 6. Yeah. Okay, so just note to make sure we know what we did. If we're just integrating with respect to y, integrate with respect to y, 2 things make sure you're careful of. Everything should be in terms of y. And something you need to miss is your limits should be in terms of y as well. And limits of integration in terms of y. So make sure you have y variables in your function that you have to do the derivative of, and your limits of integration you do in terms of y. Okay, looking at the bottom one, what is the area that's bounded by x minus 2, which is linear, a square root x, and the x-axis? What? No, it's right here. Because of the x-axis, we're only looking at the positive portion. Okay, so if we integrated this with respect to x, we would have to cut it right here. Okay? And do two separate intervals from 0 to 2 and from 2 to, so those equal to each other, but it ends up being 4. Okay? Or we could do 1 and switch everything so our horizontal rectangle is dy. Okay, even if we did it horizontally with respect to y, what's our new top? Top minus bottom. How do we set up the interval? Yep, it's this one, but we're going to have to rearrange it so it's y plus 2. Yep, y plus 2, so it's the right minus left. And we do it with dy. Now, we need to solve the left is the quadratic, so how do we get x by itself, so it's in terms of y? Squared. Yep, so x equals y squared, so minus y squared. All of that. Let's dy. Now, the limits of integration, be careful. Remember, we're doing the y's. Your limits of integration should be with respect to y. So it's from 0 to, we need to figure out what this point is. How do we figure out that intersection point? So the two is not the x-axis equal to each other, right? You can do either one. I'm going to take the originals. Square root of x equal, actually maybe the originals are more difficult because there's a square root, so I'm not going to do that one. I'm going to do y squared equals y plus 2. So we have y squared minus y minus 2 equals 0. I did the original, I have a square root in there, and that's not too fun. So two numbers that multiply to -2 and add to -1. So those are factors. So our y equals 2 and y equals -1, where they intersect. So this has to be the positive 2, minus positive 2, and plug it in. 2 squared is just 4. So we'd be iterating from 0 to, what's the y value? To 2. Okay? Should you go through and finish that problem? Is that a 1? Or a clear box? Cool. so that would be 18 thirds minus 8 thirds is 10 thirds, which is 3.3 repeating. Technically, for the repeating bar over the first three. But, okay. Any questions? Okay, let's open up your books. You guys have any homework on, right? And that's, yes, you can integrate them with respect to x, but that's not what this assignment is focusing on. We're focusing on integrating with respect to y. Instead of top minus bottom, it just switches to right minus left, which still makes sense because the right would be higher and the left would be smaller, right? Top minus bottom. I'm trying to find the homework log here. What color is it? Oh, here we go. So 8.2, 1 through 10 essentially. Find the area of the shaded region, okay? And they're so nice. They give you some of the intersection points. Okay, so you can see those are kind of crazy. If you did it with respect to x, well, the first one you can do with respect to x, right? But after the first one, it's a little crazy. Okay. And then 13, 14, 15.